Good morning, everyone. My name is Stephanie Doumtsis, and today I have the pleasure of presenting some key findings and management implications of my master's research project, which was funded by the Bill Borthwick Student Scholarship. My project was titled Beach Dynamics in Response to Varying Boundary Conditions, the Role of Rocks and Tidal Deltas, and was inspired by my desire to gain a greater understanding of our beautiful Victorian coastline. Over the past few years, our Victorian coastline has become victim to increased variations in wave conditions and storms, which is driving greater erosion than ever before. The impacts of which you can see in the pictures below, where these storms are threatening both coastal land use and infrastructure alike. As a result, our government is currently investing millions of dollars into coastal management projects. However, despite their best intentions, erosion management remains a persistent issue, and this is because the current research and models underpinning coastal management are based on entirely sandy coastlines which have an unlimited sand supply. And as such, they're not directly applicable to our Victorian coastline, which contains a lot more rock structures and other features such as inlets which moderate sand movement across the beach. As such, to gain more informed management decisions for Victoria, we need to gain a greater understanding of how our coastline operates. To gain a deeper understanding of our Victorian coastline, my research aimed to quantify and examine how beach dynamics varied through time as well as across different environmental conditions, particularly looking at the influence of rock structures and inlets on beach dynamics as they're a prevalent feature of our Victorian coast. To do this, I took a case study approach and focused on shoreline change in Inverloch, located on the southeast coast of Victoria. It's an ideal study site as it contains a variety of environmental conditions surrounding it, including rock structures and Anderson Inlet, and it has also been a site of quite significant coastal management. I used three key methods for my research. Firstly, I engaged in historical aerial analysis, which involved measuring the rates of shoreline change from 1950 through to 2020. Secondly, I collected sand samples across the coastline to identify some potential sources and sinks of sand movement. And lastly, I used drones to collect aerial images of the beach and created some 3D models from them, which I then derived some volumetrics from. The current slide highlights the rates of shoreline change which have been occurring across Inverloch from 1950 to 2020. Ultimately, areas that are red indicate erosion and those which are blue indicate areas that have been growing. From this slide, we can see that the Inverloch coastline is actually quite variable through time. Ultimately, from this slide, we can see that as our degree of rock structures decreases along the shore, we can see a trend where the coastline actually starts to shift from a more stable and accretionary state to that of erosion. This is seen on both sides of the coastline. As well as this, we see that there's this large accumulation of sand within Inverloch. When I dug into this research, I actually found that the rate of shoreline change was actually quite stable until 2012, and that was when a series of storm events happened, which contributed to sand moving from Inverloch into Inverloch. That actually only contributed to 1/6 of the total sand in that area, and the remaining sand that entered there came from PSO2 as well as the flood tide delta, which is this sand body inside of the inlet. A combination of all my results enabled me to create a really detailed understanding of sand movement in Inverloch. Ultimately, I found that the Inverloch coastline was actually a function of a past severe erosion event in 2012, which since left the coastline in an erosive state. I also found that rock structures actually act to moderate incoming wave energy and contribute to overall shoreline stability. Lastly, I found that Anderson Inlet can actually act as a source of sand as well as a sink where sand can be deposited. This is particularly important when we're considering where potential sand sources are for our coastline. The results of my research have some key practical implications. Firstly, the shoreline change analysis identified key hazard areas which required targeted and immediate management. Secondly, developing an understanding of both annual to decadal timescale changes helped me create an understanding of the recovery time of the Inverloch coastline, or be that lack of, as the Inverloch is actually now shifting into a more erosive state. This means that management should come more sooner rather than later. But this might not be the case for the entirety of the Vic coastline. Not all coastlines might shift from being stable to that of erosive. So really understanding what each coastline is doing through time is particularly important in when we're going to be implementing management, because we don't want to be wasting our money and resources on something which might naturally recover through time. Ultimately, my research also developed a really key understanding of the influence of rock structures as well as inlets on shoreline movement. This research has opportunities to be used in coastal engagement projects, as well as used to shape the sustainable management and planning of our Victorian coastline, so you and me can all enjoy a lovely day at the beach. Thank you.